says that about 82% of failures seem to be or appear to be random. We don't understand their causes. So only 18% we might be able to use some sort of a guidance mechanism. What about the remaining 82%? That means there are conditions that are arising. We don't know what that leads to. That if only we are able to surface actions from, or surface conditions rather, from within the operating information, then we can make more informed decisions. And we can do so without having to take 10 to 20 years to understand what conditions are we dealing with. So one of the biggest hurdles that we are facing in terms of smart manufacturing is the lack of labeled data sets. And when we don't have it, and we have to do the labeling, we are taking experts away from what they are doing, which is running the plant, into teaching the AI. And that slows down the manufacturing enterprise.
Okay, so Nikunj, welcome to the podcast. Thank you so much for taking the time to join us today.
Yeah, thank you for having me, and hello to your global audience.
So, to kick things off here, could you briefly introduce yourself to the audience and maybe share a bit about Falconry's journey and focus in the smart manufacturing space?
Yeah, there's going to be a lot, but I'll try to summarize it. My name is Nikunj Mehta. I'm a native of Mumbai, India, and I'm a US citizen for the last many years. I live in Cupertino, California, and it's sort of a strange place to be in this Industry 4.0 revolution, um, especially considering that almost all of the high tech manufacturing that was previously present in Silicon Valley has relocated to various parts of the world. Regardless, it is a very interesting time to be in that space. And so I found myself in 2009, at the end of my 6 years, I think, at Oracle, trying to decide what I wanted to do next. And I looked at various alternatives and I realized that clean tech was one of the spaces I could identify with. And so that led me to C3. I became an executive there. C3 is a company that focuses on AI applications and has applications in several areas, all the way from energy to defense and financial services. After 3 years there, I started Falconry as a founder, and our focus from the very beginning has been on optimizing industrial operations, and to do that with the help of data that is being produced but underexploited in the industrial context. Now, if you roll back the clock to 2012, when the company had started, there was a fair amount of talk of big data. Hadoop and HDFS were some of the hottest technologies on the scene at the time. They were also deployed in a lot of places. So not just Yahoo, but many other internet companies as well. And many commercial companies were beginning to look at how they wanted to use Hadoop and the various MapReduce capabilities that it brought for their own analysis. Now, when I started Falconry, um, two things were clear. One, that the industrial application space had not seen a substantial investment from the industrial organizations, nor a lot of attention from entrepreneurs and innovators for quite some time. I remember when I was just like an undergrad student rather, some of my friends were beginning to work in ERP, and I'm talking about late 1990s. And there was a time when a lot of manufacturing companies had adopted ERP, SAP primarily, and there was a lot of technology investment being made by those companies. Probably went on for 10 years or so. And then for the last 15 years, I think that wave had ended, and there was not much else that industrial companies had the appetite to do. I also realized that there was a lot of waste in the industrial processes. Some of it was in the form of greenhouse gas emissions. Quite a bit of it was in terms of the impact on water, land, as well as on a variety of pollutants that were being produced. And so, given that, we had number of choices to look at. Some of my colleagues would have been interested in creating more internet companies like Airbnb or um, others. And I took the path to go into clean tech. I came to C3. And the reason for doing so is I realized that the data for um, any such industrial or other space is often the starting point for a whole new set of technologies to be created to serve the needs in that space. I'd seen that at Oracle. We'd seen that with unstructured data in the NoSQL, and also with images and text still in the context of Oracle. And when I came to C3, I realized that that data type was basically various types of operational automation or business data that took the form of time series. So, long story short, the last 15 years, I guess, of my life have been focused on time series data and on how do we exploit it and how do we use it for business benefit. Um, there's a lot we will probably get to unpack, but I want to give you just the origins of how I ended up here.
That's quite a fascinating journey, and it's interesting not to know that you've been in operation since 2012. You said,
Yes, yep, 15 years
yeah,
ago. Well,
absolutely.
12 years ago, but yeah, 3 years before that at C3. So 15 years, I look at all those 15 years as time I've spent in industrial analytics.
Awesome, awesome. So let's kind of like dive into the topic of discussion today. So your company is focused on helping manufacturers drive like what you term is condition based actions for smart manufacturing.
Mhm,
So first of all, could you elaborate on the concept of condition based actions? And secondly, how do you see condition based actions integrating into the broader context of smart manufacturing?
mhm,
And maybe specifically, how do they impact key areas like maintenance, quality, reliability, and then also things like emissions?
Yeah. So there's a lot to unpack there. Let's start with condition based actions. So I think it is reasonable for us to say that a lot of decisions that get made in the manufacturing context are made based on experience. Um, and it's because the context as well as the criteria required for making decisions are just very complex and hard to state. And it's one of the reasons why it takes 5 to 7 years to become a manufacturing process engineer in a discrete manufacturing company. It's so much to absorb. So even if you're a mechanical engineer, you're not going to be able to make decisions until you've um, acted in apprenticeship for 5 to 7 years. That means that is how much context and criteria is required. Condition based actions is saying that that decision ultimately still is a human decision, but it should not take 5 to 7 years for somebody to become capable of making a decision. And how do we do that? Is there some other information or some other resource that can assist in us understanding that context and therefore making a decision at an earlier stage in our career? Now, we call that condition. The idea of condition, as we know, is it's all about what condition, when. So it's always about point in time and it's about a behavior and therefore it is dynamic. So condition, and all of us understand that in the context of industrial world, because there's a lot of condition monitoring. There's also condition-based maintenance. So the word condition is not new to us. And we've just had a tough time using condition information in our day-to-day decision making. Why? Because it's not easy to deduce conditions. And at best, we can deduce certain conditions that maybe a manufacturer has specified, or perhaps something that our uh, prior experience has indicated, has actually shown us. Now, if either of those two fall short, meaning if they don't exist, then it becomes very hard for us to understand what is the current condition. I'll give you an example. One of our customers is a steel company and they operate blast furnaces. Now, the ambient weather conditions, such as high humidity, can affect the ore they are processing because the ore tends to absorb some of that moisture. And so, therefore, when that ore goes through a blast furnace, it can be substantially more energy intensive to process. Now, the real condition here is what? Is high energy usage in the blast furnace, high moisture content of the ore, or high humidity in the atmosphere? Well, it's actually, there is cause and effect relationship, but there are three different conditions. And this is what condition based actions is all about. Now, when you think about that particular scenario, the way that excess energy is being used, it is going to affect your energy profile. It's also going to affect your emissions profile because likely you're going to be using energy that may not be clean energy. And then thirdly, it is likely to impact the lining of your blast furnace, the refractories that are used in the blast furnace. And therefore, it is going to lead to more maintenance. So as you can see, these conditions, whether they are ambient conditions, raw material conditions, or equipment and process conditions, they're all going to affect these different, if you might, outcomes of maintenance and reliability, energy, emissions, and potentially also quality. And so this is at the heart of our thesis about condition-based actions, that if only we are able to surface actions from, or surface conditions rather, from within the operating information, then we can make more informed decisions. And we can do so without having to take 10 to 20 years to understand what conditions are we dealing with, through much trial and error, and also through a lot of word of mouth and tribal knowledge, which becomes very hard to consistently apply. And so condition based actions is in a way similar to condition based maintenance, that if we can determine condition, we can take the right maintenance decision. Except in a lot of cases in the industrial domain, new conditions arise that have never arose before, that we did not know about. And we still need to be able to act, taking into account a condition that has just occurred that nobody even knew could exist, and be able to act based on that. So it is not only about conditions that we have known, that manufacturers have told us about, equipment makers have told us about, or that we have been able to root cause. So in that sense, condition-based actions is a more all-encompassing approach to taking industrial operating actions. And how it affects the various outcomes that we just mentioned. In the case of maintenance, we know that the industrial domain, this is ARC Advisory Group, which is one of the well-respected analyst firm in this space, says that about 82% of failures seem to be or appear to be random. We don't understand their causes. So only 18% we might be able to use some sort of a guidance mechanism, whether it is vibration monitoring or perhaps oil monitoring and so on. What about the remaining 82%? That means there are conditions that are arising. We don't know what that leads to. So if we are able to identify those conditions, or detect rather those conditions, then we may be able to intervene in the operation in a timely manner for purposes of improving the reliability and by taking preemptive maintenance action. Likewise, if we know that the energy usage profile is inconsistent with our ideal, we can also intervene in that regard. I'll give you another one. We had a customer that was producing shale gas through an artificial lift mechanism, just producing shale gas. And the production process, depending on how you maintain the pressure inside the well, you're likely to either produce gas or produce emission. And if you produce emission, it is also a penalty that the state is going to assign to you. And so if you are able to monitor the condition at the well bottom and know whether or not to pull out the gas at that time, enough has accumulated, then you are able to control the release of volatile organic compounds. So again, you can see how conditions are not about necessarily maintenance. They are about what is the physical state of a system that you are trying to exploit for business purpose, and which action are the best indicated given the knowledge that that condition may be happening. And so that is this philosophy of condition-based actions. Smart manufacturing, I think you said at the very end, connected to smart manufacturing. So smart manufacturing is about being more data driven and being able to take real-time actions from data that is produced in manufacturing. And conditions are of a real-time nature because they happen exactly when they happen. If you look at something 6 hours or 12 hours later, you won't see it. Yeah, I'll give you another such example. And I know I'm giving you examples because I want us to understand how this
Yes.
applies in smart manufacturing. This goes back to 2017 and 18. We were working with a mining company that was processing trona, which is a raw form of soda ash. And the United States is one of the top producers of soda ash. There is one of the largest deposits of that in the Wyoming area, Green River. And so one of our customers was finding that the variation in the grade of ore was affecting their equipment. Now, when you're in the mining industry, you don't get to control the ore precisely. Approximately, you can. So you're going to get variations in the ore. But also, you cannot get a real time assessment of the quality or grade of ore because the chemical process involves reagents and it takes some time for the reaction to finish. So it could be a few hours. And in that particular instance, it was 24 hours before they were able to deduce what is the ore grade. So the ore grade is a condition. And if it takes 24 hours for you to find out, certainly you're not going to be able to um, use that test for controlling production. So this is what I mean by real-time nature of conditions. And increasingly, we hear and see that in order for people to uh, do smart manufacturing, they need to have knowledge of the real-time condition. And therefore, actions that are made based on real-time condition are going to lead to smart manufacturing. So this is how we tie all of this together.
Oh yeah, that's super interesting. So it sounds to me like really it kind of like boils down to this ability to be able to connect to all these systems, production systems to get the data out and then do the crunching behind the scenes to be able to kind of like get those or insights or analytics that allow you to be able to sort of like nudge the customer towards an optimal path, whether it's for maintenance, quality, and so on and so forth. So I would like to kind of like peel into your uh, smart guidance solutions, as it were. And could you kind of like give us a breakdown of your solution of the framework on which you kind of like provide these smart guidance
Mhm.
solutions?
Yeah, it is important for us to realize that this condition-based actions, while um, the term is a little more general purpose than condition-based maintenance, the philosophy is similar. And we've tried to do condition-based maintenance, for example, by putting limits on temperatures and on pressures. Why? Because there could be safety issues. There could be insurance policy requirements. There could be permitting requirements, right? So therefore, we have been using condition-based actions, but in a very simple, narrow manner. Now, when we are seeking to take smart manufacturing decisions that go well beyond our ability to take actions based on condition, that's where we have to think about something smarter. Now, um, think about an analogy or a parallel. Um, we are talking about, for example, driving from point A to point B. Our historical approach to doing that was based on landmarks. Then, in the previous century, we were used to using sort of maps that were printed, map books sometimes, especially for cities, so that we could get from point A to point B. That map itself is not a smart system because all of the thinking, all of the decision making, and all of the real time intervention has to happen in the driver's side or maybe the navigator side, but it's very manual. Then, as we started to use the internet, we started to use driving directions from one or the other service. Those driving directions were still manual because any intervention you had to make in real time required that you have to think about whether this intervention is necessary and is going to take me in the right direction. So guidance system is all about, and we know a guidance system like the ones we use for navigating these days, right? It's all GPS based. The real intelligence is what is your current position and what is the context around it, meaning what else is happening, and therefore what is the guidance? Turn left, turn right, stay on, expect delay, right? Those are the kinds of guidances that we get. So in the context of smart manufacturing, we need a guidance system that is able to use the real time intelligence of condition. So replace position with condition and replace navigation or driving with manufacturing operation. That's what a guidance solution is all about. So a guidance solution by design is going to require data. So therefore, what sources of data are we going to use? Is it from a manufacturing execution system, from a SCADA, DCS, or PLC, from IIoT sensors? This is a part of this design of that solution. Now, fortunately, a lot of people already have made a number of choices and decisions in this regard. So it's not like everybody's starting from scratch. But I just want to make the audience understand that it is part of their solution for achieving or receiving guidance. Then, secondly, the systems through which a condition is determined is a part of that guidance system. The systems through which that guidance get provided to people who have to then act on it. This could be senior people like the engineering staff who have to respond to a completely new issue, or the technical staff that is making plant altering decisions, whether it is for maintenance or for operational purpose. And therefore, these three are the primary components of a smart guidance solution. For the most part, standards have made it possible now to communicate between the data sources and the guidance generating system. While there are not as many standards between the guidance system and the work management systems, that integration is now quite smooth. And so you could have 50 different source types and 50 different target types in the full gamut, if you might, of smart guidance systems and solutions. The other thing that is important to realize is that it's a solution. Therefore, the idea is that everybody's need is going to be slightly different. Their data will be slightly different, and their work systems will be slightly different. So, therefore, their specific solution is going to think about or optimize for the way that people work, meaning what information can they act on instantaneously, what information requires review. In order for them to be able to review, what is the content they will need to be provided so that they can arrive at a quick decision. And so we have to work from the perspective of people and the plant to understand how to introduce a smart guidance solution. But those are the main elements of a smart guidance solution. And we'll hopefully get a chance to go into details of what is that intelligence about the condition. What does that mean? Because naturally, that is what is new in today's time and didn't exist, say, 10 years ago.
Okay, that's super interesting. Now, what I want to kind of like focus on right now is to try and understand, because it sounds to me like this is kind of like there's many different equipment or systems or processes that you need to address with the smart guidance solutions. So naturally, that means that you're going to have to do some sort of assessment, right, as you
Mm.
deploy your solution to say what data sources are available for us to tap into, what is the process and things like that.
Yeah.
So where I'm going with this is can you give us a sense of a roadmap, or how do you typically
Mm.
roll this out? Do you
Yeah.
how do you typically approach this from start to
Yeah.
implementation?
Yes. That is a $64,000 question. So I'm glad we get to talk about it. First of all, I think we have to realize that something that is smart will also have to earn our trust. And therefore, the roadmap has to start from how do we build trust? And that means we need people who are, um, you know, who hold a strong reputation within our field or within our organization or within our plant, um, to have to take the first steps in moving the organization towards a smart guidance solution. So that's the first element of a roadmap. The second element is there a way for us to know how smart is this system before we start making decisions based on it, real-time decisions? Now, to do that, many organizations tend to use a guidance system in retrospect, meaning what was going on at time t when an incident occurred. And what does this smart system know about what was happening at time t? Is it able to indicate that there was a behavior or a condition that needed action? Number one. And two, is it able to help us understand what may the causes have been for it thinking that there is an active condition that requires intervention? Now, if we can do these things, then at the time an incident occurs, somebody is going to ask a question: why did this happen? What do we do? And we don't have a lot of time to answer or find the answer. And a smart guidance system should at least be able to tell us what were the proximate causes. Because if it is able to do that work, then we can improve our recovery process. Now, in order for us to be able to get to the root cause, naturally, we are going to have to provide it data. So the typical approach that manufacturing organizations take is that they will connect either IIoT sensor data, or they will connect SCADA data to a Falconry type of smart system. And they would do that through some industrial middleware technology, something that they can keep in the plant that is secure and is able to move data for an entire line, or potentially for a plant if it is a secondary sensing like IIoT sensor, and use a line worth of information or a subsystem worth of information, a few thousand parameters or a few hundred parameters, depending on everybody's comfort level. Not knowing necessarily which conditions can be predicted from those parameters and when that condition is going to occur. So we don't know that. What we do know is that we want to have a team that is focused on a certain line and has reputation within the organization, therefore is going to do this introduction of a smart system into that manufacturing organization. So those are the three elements. Now, once the root cause once the system is beginning to be used for root cause, at that point, I think people develop a sense of what is the level of intelligence of this guidance system. And therefore, whether we'll get down to, instead of the 82% failures are random, we'll get down to maybe 35% failures are random. And for the other 50%, we can use a guidance system. And then for another 20%, we can use conventional systems. Once we get to that level of confidence or belief, at that point, we want to turn this system into an alerting system. And generally, in order for something to become an alerting system, it has to have relatively low incidence rate that people will actually act upon it. And so transitioning or sort of switching from a root cause or an analysis system to an alerting system is going to go through that kind of a review and robustification process to make sure that it does not make the lives of people working in the plant worse, and that they are able to understand what alerts are telling them. And generally, to me, alerting also goes with integrating into work systems, because people are used to working and keeping track of their work and compliance through those work systems. And so at the time people are ready for an alerting system, they also expect that the alerting system will integrate with their work systems, and do so in such a way that the information is adequate for them to take the next action. So that's sort of the roadmap. I'll just summarize. First is the leaders that are trustworthy. Second is an analysis system for a certain line where the trustworthy people have expertise. And then the third is an alerting system that is integrated into the work management stream that can be used to communicate conditions and the likely actions to take based on those conditions.
So, I mean, in terms of the of addressing use cases, because how I imagine it from your description so far is that ultimately what you're going to have is this unified data platform that gives you smart guidance for your maintenance, quality, and all the difference within that unified platform. But in terms of addressing the use cases, do you pick use case by use case to say first we start with maintenance and then move to quality and so on and so forth? How is that
Yeah.
typically approached?
Very good question. Um, I think what you've done just now is you have used the word use case in a way that makes a lot of sense, because in the past, people have used the word use case to imply a particular failure mode. And it is very hard to address just one failure mode in a cost effective way. So naturally, everybody gets stuck. They cannot scale it, the approach that they've come up with, and they cannot deliver the benefit to a business because that failure mode may not happen for a very long time. Even if you have the right solution, it doesn't produce value until the failure mode occurs. On the other hand, when you say the use case is maintenance or it is emissions, it works a lot differently. Now, where do people start? They generally do start with one use case. Often that use case tends to be about reliability or about process improvement, or I guess process optimization. Um, Sometimes we end up working with process engineers who have an ongoing open topic to improve energy efficiency, for example. And therefore, their attention will be how do we improve process while reducing energy? Or sometimes, as I gave you the example of the blast furnace, they are interested in reducing the maintenance demand on the furnace by controlling the energy and the temperature inside the furnace. So it may be originating from we have too much maintenance and therefore too much downtime to improving the process. Now, this is where I think it is, at least to me, it is becoming apparent that maintenance technologies, especially in the context of smart manufacturing, are often seen as something that is for the benefit of the maintenance team and is used only by the maintenance team, or maybe a data scientist, but not anybody else. What we are realizing is that smart manufacturing is going to require engineering in much the same way that perhaps a new manufacturing process requires engineering. And so we tend to work best when we work with the engineering team because for them, conditions are a new kind of resource. They will exploit it to optimize the entire plant's operation, not only one objective such as maintenance, but they usually will start from one. So hopefully, I'm helping you understand how people start. They start with the intention of improving either maintenance or the process. And process is pretty broad. We've seen that occur a few times, and therefore I don't feel that people are wrong about it. And then they grow from that into energy as well as into quality.
Okay. So do you have some just kind of like get sort of like paint a picture for our audience here? Do you have some example improvement numbers or percentages that you could share with us? Maybe an example case study?
Yes, so a number of Falconry customers are operating Falconry in the analysis mode. A few of them also operate Falconry in an ongoing alerting mode. And what we've seen is that when customers have used Falconry in analysis modes, the returns on their investment tend to be in the high six figures or even the low seven figures. And this is for a single line. It is often because they are able to reduce the lost production time, which can range anywhere between an hour or 2 hours and 2 days. That's how much production loss an organization may incur. One specific example we have published is with ArcelorMittal and their Calvert-based cold rolling plant used to suffer about 4% of unproductive time that was lost to a condition called breaks in the metal that is being processed. And 3 to 4% generally translates to $4 to $5 million a year. And so Falconry was able to provide them a way to reduce the unproductive time down by a percent, basically. So instead of 3 to 4%, reducing it down by 1%. And so that translated into $1 million of gain just for that plant. And this is a study we've published, and we've presented it at the Association of Iron and Steel Technology.
Yeah, so maybe to get a bit technical, yeah. So I mean, you mentioned that this idea that you've got the guidance system or your alerts, like sort of like integrating with the work system or existing infrastructure of whatever infrastructure the company already has currently. So what I want to understand is, as far as data integration standards, do you have a preference to what standards you integrate with, or do you have recommendation? What are the best practices here around
Yeah.
standards for data integration?
This is a question I'm learning a lot about in the last 2 years. I think MQTT as a data communication protocol and one that is used inside the factory has been known for quite some time. I remember meeting with ArcelorMittal in 2017. Probably it was even earlier than that. Maybe it was 2016. And I learned about MQTT and all of the work that Cirrus Logic was doing back then. So it's almost 9 years, 8 years ago. And even though I had known about it, I found that a lot of organizations were acting independently of IT in making some of these choices about how they want to communicate between their infrastructure and Falconry. One of the interesting things I observed was that companies that are expecting to perform analysis on high-speed data, for example, that happens in steel making, in aluminum processing, they tend to produce data from a single physical quantity or a sensor, sometimes 10, sometimes 100, sometimes even 200 times a second. And I noticed that for them, it made more sense to transfer Parquet files every few minutes, 5 minutes perhaps, and put that into an S3 bucket. So our experience is that those organizations who are doing processing or that want to use slower data, for example, in energy production sites like oil, gas, or other such extraction mechanisms, they tend to use MQTT. And those organizations that are running a high-speed production line or high-speed control logic, they want to use a Parquet type of file mechanism. And in my opinion, I think we have to be prepared for a hybrid until we are able to do both in a single mechanism.
The other issue that I want to speak about is the issue of skilled workforce. So I mentioned this to a previous guest on the podcast that when I was sort of researching for this podcast and I read a lot of reports and a lot of research, one of the things that stood out that manufacturing leaders were pointing to as one of the biggest stumbling blocks in adopting AI or implementing AI was the lack of skilled workforce for these AI solutions. So, what I want to get a sense from you is what sort of skill sets are required for developing and maintaining Falconry's smart guidance solutions.
Yeah, very good question. I mean, in general, we are going through the maturation process of a technology like AI. But more importantly, we are going through the maturation process of solutions that incorporate AI. And inevitably, AI is going to become invisible to most organizations that are using it. And it should. I don't think that it is possible to have a lot of people who can tinker with AI that is already in production. It's very hard. Um, so the workforce that, if you might, 6, 7 years ago, was that every manufacturing company has to hire a team of data scientists and then hold on to them until the systems go into production and they are able to get benefit across the enterprise. That's a 20-year roadmap. That was not feasible. And I think enough organizations have recognized that just hiring data scientists and having them churn out algorithmic source of solutions to individual problems does not move them forward. It might give them confidence that there is a path forward. It doesn't really move them forward. That is data scientists. Likewise, there's another crowd of people, data engineers. And data engineers' main job is to move and prepare data for processing. And we believe that even that is very hard to scale for most organizations. And I say this having come out of a place like Oracle. It is possible to do a lot with just one standard piece of software, and you don't need to have lots of people for every project doing the same kind of work. But especially so in AI, where the data preparation process is, especially in the industrial world, it's very difficult. And not many people understand that you can do that through a common approach and make it successfully work with AI systems. And I'll give you just a couple of very quick examples. We know that there is a lot of compression in data that is produced in manufacturing. And therefore, alignment of the values across different physical streams is not perfect. How do you process such data? Now, ordinarily, people do a lot of reconstruction to align it. And when they do that, they're creating somewhat bespoke solutions. Um, and oftentimes, they are removing quite a bit of the information. And that can have its own side effects. But that work of data engineering is also suboptimal in terms of the value you will get for money. Now, the type of workforce that is indeed valuable and highly necessary is the navigator who can take this guidance, or I'm saying navigator or the driver, maybe whichever way you want to think about it. The driver is the one who's taking this guidance and saying, okay, I'm going to turn left. Now, when they decide they're going to turn left, the wheels are doing the work, right? The driver is just making the decision. I'm going to turn left. In um, in a real world organization, those drivers sometimes they are called advanced maintenance teams, and we've seen this in many different steel companies all over the world. In Mexico, in Scandinavia, in Canada, in the US. So we believe this is going to be relatively consistent in at least the steel industry. And I have a feeling that this is going to be true also in other industries, that the advanced maintenance team is going to be built from a combination of those who have done maintenance for a long time and those who have just come out of mechanical engineering or electrical engineering and want to be a part of a manufacturing organization. Um, Neither of which are software engineers, mathematicians, physicists, right? I don't expect them to be a part of that workforce.
That makes a lot of sense. So, I mean, from our discussion here today, it's clear that at the core of your smart guidance solutions, it is this idea of the automation of analytics processes, right? And I know you've alluded to the significance of that, but I want us to kind of like dwell into that a bit. How is significant is the impact of automated analytics processes?
Yeah, I don't think I can overstate it. The analogy is very clear. For almost a century, um, linguists were constructing mathematical models of language, and you and I ordinarily we didn't see any benefit from that. It was all scientific progress, but one without really impacting society. And then in the last 20 years, let's just say from the time Google went public till now, they have been using computational methods, which is heavily statistics driven, without necessarily understanding the model of language. And they have made a ton of progress. And today, you and I can use ChatGPT to do ordinary things. And so therefore, there is social impact from that. In a similar way, these analytical methods that can extract sort of insights as well as guidance from our operational data um, are of a similar kind, the second kind. Now, a lot of times, the approaches people take are to create a specific equation, a specific algorithm, or a specific pipeline that is suitable for a failure mode, or sometimes even for an entire use case. And those approaches are hard to create in the first place because you have to have intimate understanding of physics and be able to do that with data. In my opinion, that path is really a dead end. We may make a little bit of progress, but we're going to get into that dead end. For the simple reason that when governing laws are known and we can create a physics based model, we will omit those things that do not allow us to create a clean model. And that, what we omit, is the real world. So, those approaches, which are either physics models or equation based, they have already done a lot of work. The gap that remains is not going to be filled by that approach. And in just the same way that autonomous driving went from individual use case, I have to turn a corner, I am driving through a rural road, etc. Every one of them was one block within the overall intelligence. Soon enough, it got replaced by deep learning.
Yeah.
And that is what is happening even for condition intelligence. And so, what Falconry has done is we have taken a deep learning approach to understand what conditions are happening. Those may be in the form of the statistical deviation from mean. They may be about a high limit or a low limit, which are easy things, but they could be about shapes, waveforms, distributions, um, frequencies, and naturally correlations across many of these such waveforms and shapes. And what we have found is that it is impossible to do all of this, what I just described, in a computationally efficient and an understandable way with conventional methods. And with deep learning, it is actually possible to do it in a computationally efficient way and an explainable way and in a generalized way, such that it can be benefiting many different scenarios. So, that I think innovation is essential. And unless we are able to use general methods, condition based actions will not make any impact on society.
Yeah. I mean, as you have kind of like aptly really pointed out that manufacturing is kind of like it's an industry that is deeply rooted in sort of like decision making based on physics behind machines and processes. And so this shift from physics based to data driven operations often brings up these cultural challenges again, as you have rightly pointed out. So from a management point of view, like how what strategies do you recommend for manufacturing leaders to manage this transition, to move from physics based to data driven decision making?
Yeah, I would say take help from societies, organizations, government institutions, and others that are advocating for smart. Look, smart is about data. Our previous generation industry 3.0 was powered by electronics. The previous one was powered by electricity. The previous one by mechanical force, right? This fourth one is going to be powered by data. Let's be clear about that. Therefore, if all of us, all of mankind, understand it's going to be powered by data, then we have to simply figure out how do we as an organization want to leverage data for our own benefit. Secondly, keep trust front and center. Remember, trust and verify, or trust but verify, is the basis for a lot of society. It is going to be important even in smart manufacturing. And I do believe that people are able to set up experiments to develop trust, as I described that earlier in our podcast. And to the extent that their organizations are constantly thinking about trust, they will be able to make progress and power their own manufacturing operations with data.
So I mean, in the past few years, we have seen manufacturers take a somewhat relatively slow approach to adoption and implementation of these smart or AI solutions. Um, what do you see as the key factors that contribute to these slow trial processes, and what strategies can companies adopt to accelerate this
Very
process?
good question. In fact, pre-pandemic and post-pandemic are quite different, but its correlation is not the same as cause effect, right? It's not the pandemic that has sped up everything. I mean, I do think that the realignment of supply chains is doing a fair bit with it, but I think the arrival of smarter or of computationally more effective approaches like deep learning have also made a substantial difference. It's made a difference to our customers. It's making a difference to us. And the reason for it is that it is able to move through things much faster. And it is a lot less dependent on people. So one of the biggest hurdles that we are facing in terms of smart manufacturing is the lack of labeled data sets. And when we don't have it, and we have to do the labeling, we are taking experts away from what they are doing, which is running the plant, into teaching the AI. And that slows down the manufacturing enterprise. It slows down the manufacturing sector. They don't have such spare people. Anyway, we are talking about a retirement sort of cliff for a lot of these organizations. So the whole productivity, if you might, plateauing that has happened in the last 10 years is because we are not getting as much out of technology as we are putting into it. So that's likely result of experts being drawn out of manufacturing and being asked to help move AI forward. We need to shift that, and we need to first create smart findings without people having to put a lot of effort in to create that. That's why I said physics, labeling, like these are mechanisms that are unproductive. They are not moving us forward. We need better technology than that. And to me, that is the main breakthrough that happened in these last 3 years or so. Just like ChatGPT, I mean, it's the same reason why ChatGPT has broke through. It's the deep learning progress that happened in the 2019 to 2021 timeframe.
Awesome. So, I mean, we're running out of time here. So maybe to kind of like bring everything home here for manufacturing leaders who are listening to this conversation right now and are just beginning to start thinking about adopting smart technologies or kind of like integrating smart technologies into their operations. What advice would you have for them? How should they think about this? What should they do, and so on?
Yeah, see, I think it is now conventional wisdom that scaling is very difficult, and that many approaches are either failure mode specific or root cause specific. So the one advice I'll give smart manufacturing leaders is to differentiate between their own internal efforts for data science or other smart operations from those that are commercially available. In the same way that the government is choosing to use commercial off the shelf, it's a more sustainable practice for the long term. Manufacturers also will need to do the same. You will have data scientists, but those should be for governance. Those should be for specific optimization problems that are peculiar to those organizations. I would also say that smart manufacturing in general should be led by an executive level person, because we've seen way too many times delays in decision making arise from the fact that it is not an executive decision. And therefore, people wait for executives to give it attention. I don't see that as a productive practice when the economics behind such approaches has already been worked out to a point there is enough ROI. And so now the real risk taking is in the hands of executives. It's no longer a technical risk, it is a business risk. And for that, you need executives to take responsibility. So I'd just say those two things, data scientists for bespoke needs, and responsibility for business risk and decision making in the hands of executives are two essential, if you might, elements of a strategy to move smart manufacturing faster forward.
Awesome. Thank you so much, Nikunj, for your time today. So we're certainly going to provide links to your website, your LinkedIn profile, and all the relevant material in the description below for all of those who want to access it. But besides that, do you have any last words that you want to
Yeah,
say to the audience?
I do want to say that over these 15 years, there are a lot of people I've learned from. Some of them are evangelists or analysts like yourself, Kudzai, but I've also had the luxury of working with a team over all of these years who have actually designed and built many of these systems. I have only observed what the effects are of applying those systems in practice. And I do think that this industrial space truly needs to respect those who are enduring a lot of hardships to get them to a place of promise. And I think it is important for us to take into account all of the work that has happened before us that allows us to talk about more advanced things today. So that's the one thing I wanted to say is Falconry is that kind of a place where we have accumulated experience over the last 12 years of intelligent solutions. And AI is really only been true in the last 2 years. Everything before that was not AI, no matter what anybody says.
Awesome stuff. So again, Nikunj, thank you so much for taking your time to join us today and share your insights with the audience. Really appreciate it.
Thank you, Kudzai. Thanks for having me.